All right, question 4C. Again, we're solving by factoring here. Now, first of all, notice I've got this 2p minus 1 squared inside there. It looks to me like there's another level to the algebra here. So for right now, I'm just going to let that equal a. I'm going to let 2p minus 1 be a. So here I'm going to get a squared plus 4 is equal to 53. I'll deal with that 2p minus 1 later once I've dealt with the first level of algebra here. To solve this is a quadratic, so to solve it, I need to set this thing equal to 0. So I'm going to bring the 53 over. That's going to get a squared minus 49. Okay, and that's going to be equal to 0. Okay. Again, because it's a quadratic, I need this to be equal to 0 so that I can solve that. And that's just going to be a general rule here. Now what I'm going to do is I take a look at this and I see I've got two terms with a subtraction in between. So this is a difference of squares. So a minus 7, a plus 7 equals 0. And now to solve that, you put these together here. Either this factor, a minus 7 is equal to 0, or a plus 7 is equal to 0. One of those two has got to be true if the product of those two terms is giving me a 0. Which means either a is equal to 7 or a is equal to negative 7. See, again, that's the only way, when you've got two things multiplied together, that's the only way you can get a 0 is if one of those or both of them go to 0. Now, that tells me that a is either 7 or a is either negative 7. But a wasn't part of the question. A was 2p minus 1. So in both of those, I'm going to put 2p minus 1. So in this case here, it's going to be 2p is equal to 8 when I bring the 1 over. P is equal to 4. Or over here, 2p, if I add the 1 over, that's going to be negative 6. And so, oops, I wanted to write a 2p, but I've already isolated that, so give me a second there. If I divide there, that's going to be p is equal to negative 3. So either of those two solutions, p equal to 4 or p equal to negative 3, will solve that equation.